Hey everybody, and this is Mr. G, and this is the video for solving systems of inequalities. This is the first part of the video. I'm going to have probably two, maybe even possibly three parts to this video. So this is just the beginning of systems of inequalities, and once you're ready to move on, you can move on to part two. So our objective today is we're going to be able to solve systems of inequalities by graphing. So the first thing what I want to do though is I want us to graph these two equations on the same coordinate plane. I want to graph the equation y equals 3 and x equals 4 on the same coordinate plane. And this is kind of what we're going to be doing today, but we're going to change these into inequalities. So if I were to graph y equals 3, I'm going to do that one in blue right here. Y equals 3, I know if I were to graph that on a coordinate plane, I would have y equals 3 would be right here, because this is where y is 3, right? But I'm going to have a horizontal line right here on y equals 3, because for all of these solutions on this coordinate plane, y is 3. So every single point on this line, here, 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 y is 3. My x value changes, but my y is still 3 no matter what point I find. Okay? So when we graph the line y equals 3, everything on that line is our solution. Okay, now I'm going to do a different color. We'll go red. I'm going to graph x is equal to 4. So I would see x is 4. That'd be 1, 2, 3, 4. And it'd be a vertical line on x is equal to 4. Okay. And this red line right here would be the graph for x is equal to 4. Because again, any point on this line here, x is equal to 4. My y value is changing because I'm going up and down, but my x value stays the same. Okay, and so any solution on this line, any point on this line is a solution to x equals 4. Now, if this was a system of equations, our solution would be this point of intersection right here, where the two lines cross. And that would be the point, what is this, 4, 3. Because my x is equal to 4, my y is equal to 3. This right here is a system of equations. This is where they overlap. This is the solution to this system of equations. Okay, because this solution right here, 4, 3, works for both of these equations. Now, things change when we have inequalities. Okay, and because the reason why is if, say I change this, instead of to x equals 4, what if I change this to x is less than or equal to 4? Now, I have a lot more solutions than just what's on this line. Now, when I have x is less than or equal to 4, I would still graph, my x is equal to 4 is still the same line. But now that I have x is less than or equal to 4, everything on this line is still a solution. Okay, because it's less than or equal to 4. So everything on here is still equal to 4, and it says or equal to. But isn't all these values right here also less than 4? Still, okay, because this is all x is equal is 3. This is x is 2, x is 1. So that means all of these values over here are solutions. So there's a lot of solutions for x is less than or equal to 4. And that's why inequalities are a little bit different than equations. So what we're going to do first is we are going to just graph one inequality on a graph on a coordinate plane just to see what it looks like, and then we're going to create a system. Okay, so first let's graph this inequality right here of y is greater than or equal to negative 2. So when I graph this, I'm going to treat this just like the graph y is equal to negative 2. Okay, because we graph it the same, the graphing process is still the same. I still need to find the graph for y is equal to negative 2. So I'm going to find y is negative 2, which is going to be right here because this would be negative 2. And I have a horizontal line. I'm going to try to make this as straight as possible. Not bad. Okay. So I have my horizontal line. There's my graph for y is equal to negative 2. Now I'm going to forget like I graphed y is equal to negative 2. And I realize, okay, now I have y is greater than or equal to negative 2. Okay, greater than or equal to negative 2. Well, if y was greater than or equal to negative 2, all of these values up here are still greater than negative 2, right? Because isn't this negative 1? 0 is bigger than negative 2. 1 is bigger than negative 2. 2 is bigger than negative 2. So all of these, and it goes infinitely forever. It goes for infinity this direction. So that means I'm going to shade in. I'll do this with my pencil, but I'm showing you with a highlighter right now. I would shade in all of this for this graph, showing that all of these solutions are included. Okay? So all of this, all of the yellow and the blue line is a solution to the graph or to the equation or the inequality y is greater than or equal to -2. And I'm done. This is the graph for y is greater than or equal to -2. I have my line for what y equals -2 would be. But then because y is greater than -2, everything above that line, because y is greater than, everything above the line is going to be part of my solution. Because all of these values are greater than -2. Okay? Now, one thing when we're graphing inequalities and we have our symbols, one thing we need to be careful of is our signs. Okay? We have our signs. If we have the signs that are just less than or greater than, we need to use the dashed line when we're graphing our line. If we have a sign that's less than or equal to or greater than or equal to, we need to use a solid line. Okay, here's one thing that I like to use to help me memorize this. Okay, if I have my less than or greater than symbols, okay, I know when we used to graph on a number line, when we had these symbols, we would always use a closed circle. And then here we're going to use a solid line. So look, it makes a face. This looks like someone that's trying to sleep, maybe. Okay. Now, if I have, I'll make an angry face here, greater than or less than, on the number line, we would graph it with an open circle. And then on the coordinate plane, we use a dashed line. So these are two faces that I like to use to help me memorize when to use a dashed line or a solid line. Okay. So hopefully those will help you out as well. Okay, so that's just one little technicality when graphing systems of inequalities or graphing inequalities in general, but let's look at some more here. So now I have the system y is less than or equal to 5 and x is less than 3. So now I have two equations, or two inequalities, and I'm going to graph them on the same coordinate plane. And just like what we did earlier when we had a system of equations, so before when we graphed y equals 3 and x equals 4, we found their point of intersection, where both of their solutions overlap each other. We're going to do the same thing, but now we have an inequality, so we're going to have a lot of solutions. So we need to see where both of our solutions overlap, and there's going to be multiple solutions here. So let's do that. Okay, so first I'm going to we'll graph this one in blue. Y is less than or equal to 5. So I need to find y is less than or equal to 5. So 5 would be 1, 2, 3, 4, 5. There's 5. So it's less than or equal to, so I'm going to have a solid line. There's my graph for y is less than or equal to 5. Okay. Now, what I want to do is I still want to do my shading and make sure I shade correctly here. So let's shade this one in blue, actually. So when I shade, if y is less than or equal to 5, I need to ask myself, is it going to be above this line or below this line? Well, if it's less than, it's going to be below. So here is my solution right here. Okay, it's all of these solutions, and it's going to go down for a long time. Okay, I'll do my best. Okay, there we go. So there's my graph. Y is less than or equal to 5. Now what I'm going to do is I'm going to graph x is less than 3. Okay, so I need to graph my line of x is less than 3. So that would be 1, 2, 3. So here's x is 3. So I have a vertical line here. Okay. Oops, there we go. For x is equal to 3. And then now I realize I just made a mistake. This says x is less than 3. So what I need to do is I actually need to, let's just actually undo this here. Is this going to work? There we go. I need to do a dashed line because it's less than 3. So 1, 2, 3. I have a dashed line on 3. The reason why it's dashed again is because x is less than, it's not or equal to. So this dashed line means anything on this line is not part of the solution. So anything on this line is not part of the solution. That's why it's a dashed line. So now I have my dashed line for x is less than 3, and I need to do my highlighting. Okay, I need to do my shading. I need to figure out, okay, well, x is less than 3, so are all of my solutions going to be to the left of this line, or are they going to be to the right of this line? Well, x is less than 3, all my solutions should be to the left. So they should be over here, to the left of my line. And these are all of my solutions right here. Okay. And then even all of these are solutions too. Those are all to the left of x is less than 3. So now for this system of inequalities, I'm trying to figure out where do the shadings overlap each other? Okay, where are there solutions for both of these that exist? And that would be this section right here. This would be my solution. So any point right here on the graph in this section, I can choose this point, anywhere over here, because this is where I have blue shading and red shading, is in this corner of the graph. Any of these points are both less than 3, or satisfy the inequality of x is less than 3 and y is less than or equal to 5. Okay, and that would be anything over here. Any of these points. If I grab this point 0, 0. Okay, let's just test this point 0, 0 real quick. If I were to plug in 0, 0 into these inequalities, so when y is 0, is y less than or equal to negative 5? And then is 0 less than 3? And both of these are true. That is why this is a solution to this system, because it satisfies both inequalities. And that's how we do systems of inequalities. We graph both of them, we shade our solutions, and then we see where the shadings overlap, and that is our actual solution, because all of these are solutions to this inequality. There's not just one solution anymore. There are multiple. There's many solutions, okay? Let's look at another one. So I have y is greater than negative 5. Okay, let's grab that one. Let's do like blue and orange this time. I'll grab this one in orange. Okay, so this will be my orange one. So y is greater than negative 5. So 1, 2, 3, 4, 5. So here's negative 5. And again, I did it again. Dashed line. Got to be careful about that. It's a dashed line because y is greater than negative 5. So make sure right away, right when you see this sign, say, okay, am I going to have a dashed line or am I going to have a solid line? This one's a dashed line. Okay, and then now I need to decide, do I need to shade above or below? Well, y is greater than negative 5, so I'm going to shade above. So there's my shading. Okay, now let's do my next one. We'll do this one in blue. And we'll do y is less than or equal to negative 1. Because it's less than or equal to, I know I can use a solid line, so that makes that a little bit easier. And negative 1 for y is negative 1 is right here. So I have a solid line on y is equal to negative 1. And I know that y is less than negative 1. I don't want an eraser, I want a highlighter. There we go. So less than means everything below the line is going to be a solution. So that means all of this. You know what? I'm just going to stop right here because I see that this is where I overlapped, and I'm done. There's my solution to the graph right here. Okay, so none of this up here is part of my solution. Okay, this is not part of the solution because this is not where the graph overlapped. The only part of my solution is where the graph overlapped, which is this piece right here in the middle, in between them. Because this is where y is greater than negative 5 and y is less than or equal to negative 1. Okay, let's look at one more. This one's kind of a unique one. I need to stop doing that. Let me exit out. There we go. So I have x is less than negative 5. So let's go ahead and graph this one first. Right away, if I notice, I need to do a dashed line here, and I'll do it in blue. So x is less than negative 5. So I have 1, 2, 3, 4, 5. Here's x is negative 5. So I'm going to have a vertical line. It's going to be dashed because it's just less than. There is no or equal to. So that means all the solutions on this dashed line are not part of the solution. Okay. And now I also have x is greater than negative 1. Again, I need a dashed line. I need to find negative 1, which is right here. And let's do my dashed line. So those are my two graphs. So now let's do my shading. Let's see where these two guys shade. So if I were to do, let's stick with the same inequality here. X is greater than negative 1. Well, if x is greater than negative 1, all the numbers to values to the right are greater than negative 1. So here would be my shading for x is greater than negative 1. I would shade all of these over here. Okay. And then now let's shade for our first graph. X is less than negative 5. Well, here's negative 5, and x is less than negative 5. So that means I would shade all the values to the left because this is negative 6, negative 7, negative 8, and those are less than negative 5. So here would be my shading over here. Now, what do we notice about this graph, this system of inequalities? There is a big gap here, and these two inequalities are solutions. They never overlap. There's no shading that overlap each other. So that means for this inequality, for this particular system, there is no solution. There is no possible solution that could satisfy both of these inequalities. We cannot find one point, one ordered pair on this coordinate plane that would work for both x is less than -5 and x is greater than -1. It does not exist. Okay, so be careful of that too. So remember, just a quick recap, and then we're going to be all done. When we're graphing systems of inequalities, okay, when we're graphing systems of inequalities, first we just graph the inequality as if it was a line in an equation, not just an inequality, and then but now we shade our solution depending on whether it's less than or greater than, or less than or equal to, or greater than or equal to. We also make sure we use a dashed line when doing those graphs if it is less than or greater than, and we use a solid line if it's less than or equal to or greater than or equal to. And then our solution is always going to be this section where our shadings overlap once we graph our two inequalities on the same coordinate plane. So if we graph two inequalities on the same coordinate plane where their solutions overlap each other, which there should be multiple solutions, that is your solution to the system of inequalities. Okay, so I hope that this video helped. Good luck, and thanks for listening.